Hello, dear students. Welcome back to MKG Online Study and e-learning platform. You already know how gates work and or a flip-flop, maybe a mux. You can draw that stuff by hand and it makes sense. Cool. But by the end of this video, you are gonna understand why nobody in the real world design chips that way and why we are about to spend a whole playlist learning to create code instead. Let's go. Uh, your phone's chip has like 10 billion transistors in it. 10 billion. Think about it like this. Drawing a chip gate by gate is like trying to build the entire city of Mumbai brick by brick by hand alone with tweezers. Technically possible in theory, actually impossible in practice. Nobody sat there and drew 10 billion gates. So the real question isn't how do gates work? You know that already. The real question is how do you go from a handful of gates you understand to a literally city of them? Left side you can see a 4-bit adder. Clean, cute. You could sketch this on a napkin. Right side, that's what a real chip's logic actually looks like zoomed out. That's not even a real chip, by the way, that's a simplified representation and it's already unreadable. This is basically the difference between writing a text to your friend versus handwriting every page of a 500-page novel. Same scale, completely different scale, and once you hit that scale, drawing schematics just stop being an option. So here is the plot twist. Verilog looks like code, Kinda like Python or C, but it is not the same thing. And if you carry that assumption in, you are going to be confused for weeks. A normal programming language is like a recipe. Do step 1, then step 2, then step 3 in order one at a time. Verilog is not a recipe. Verilog is more like architectural blueprints. You are not telling someone what to do. You are describing something that will exist. Walls here, wiring there, plumbing over there, and none of it happens in order. It's just all three. All at once, the moment the house is built. That's literally what Verilog does. You are not writing instructions for a processor to run. You are describing wires, gates, and flip-flops that will physically exist on a chip. Hardware doesn't run line by line, it runs all at once. This is the single biggest mindset in this entire course. So I need you locked in for this one sentence. Hardware doesn't learn line by line. It runs all at once. Think of code like a single chef in a kitchen, single chef in a kitchen, one person, one task at a time, top to bottom. Hardware is more like an entire kitchen staff on a busy Friday night. The grill guy, the salad station, the guy plating desserts, all working simultaneously, all the time, nobody waiting in line for their turn. That's called concurrency. And it's the whole reason Verilog feels wired at first. If you are coming from C or Python, keep this in your head. We are coming back to it constantly. Okay, so here's why any of this actually matters outside of passing this class. The Verilog you write connect directly to a real physical chip. Watch the pipeline. You write the code, you simulate it, Basically, a dress rehearsal to check it behaves right. A tool called synthesis turns your code into an actual gate level circuit. Place and route arranges those gates physically on the silicon. And then a foundry manufactures the real chip. It's basically the difference between writing a song on a paper versus it actually playing on the radio. Every unit in this playlist is you getting better at the first step, writing clean code that survives the whole pipeline. Now here is the stakes, and this is not dramatic. This is literally the industry. If, if a mistake in your design slips all the way through the fabrication, fixing it doesn't mean control Z. It means remanufacturing the physical chip. That's your $1 to $3 million mistake. Easy and months of delay. It's really realizing your typo after the book already got printed 1 million copies. You can't just fix a file, the damage is already physical. That's exactly why Unit 5 exists. Test benches, verification, all of it. It's not an afterthought tacked onto the end of the syllabus. It's your insurance policy before anything gets built for real. So, here where we are headed, we are going to build the exact same circuit, decoder, muxes, flip-flops, counters, three completely different ways, gate level, data flow, behavioral. Think of it like learning to cook the same dish three ways. First, following an exact recipe step by step, then with shortcuts, once you know what you are doing, then eventually just knowing I want it spicy and crispy and trusting yourself to make it happen. Same dish, different level of control versus convenience. That's literally the arc of this whole course. And we close it out with a real mini project where you build and verify something from scratch. So that's the way Gates got you started. HDL is what actually ships. So, dear students, if you enjoy this journey, then hit the thumbs up button, share this video with your friends, and do subscribe the channel. See you in the next video, the full VLSI design flow. Thanks for watching and enjoy this Verilog HDL playlist or journey.